Let us now take this problem of problem 59 of your textbook of concepts of physics, C Verma. The figure is very clear. There is a body of 2 kg here, and there is a body of 4 kg here. And the body A moves towards the body B with a velocity of 1 meter per second, is given. And before collision, they have a separation of 16 meter per second, 16 centimeter. 16 centimeter is equal to 0.16 meter. That means body A will have to move 0.16 meter before collision. And what is given? There is a friction coefficient of 0.2. That means here there is a mu of collision is perfectly elastic, absolutely fine. Find the separation between the two blocks when they come to rest. This is the question, the separation distance between the two blocks. Now, how do we proceed? This is before collision. This is the initial condition. I should write initial condition. And just before collision, what will happen? Just before collision, this is the block of 4 kg, block B, and this is the block B. Before collision, just before collision, they will be touching each other. But for the sake of the drawing, I am writing it with a little gap. This is A, this is B. And so we write here just before collision. Now, the body A started with a velocity of 1 meter per second. But since there is a friction, its velocity here will no more 1 meter per second. Its velocity here will be something different. Let us say its velocity here is 1. Because in our textbook, we have been always telling U1, U2, G1, G2. Let's say its velocity is U1. B is, of course, at rest. So it is very clear we have to find out the value of U1. Right? So how do we find out the value of U1? That is also very clear. Since the frictional coefficient of B is given, we can find the frictional force. Initial velocity is given, 1 meter per second. So we can always find out what will be its velocity when it moves 16 centimeters. Right? So what is the frictional force? Frictional force, we write frictional against the velocity of A. Frictional force is mu mg. M is 2 kg and g is 10. Mu mg, which is mu is given 0.2 and that multiplied by 2, that multiplied by 10. So frictional forces, 2 are 2, 4. Now this frictional force acts in the opposite direction, Fs. So definitely it will create a retardation or negative acceleration on A. What is that negative acceleration? We know A is equal to the force by mass. The force is acting in opposite direction. So force is 4 Newton by mass is 2 kg equal to minus 2 meter per second square. Fine. So acceleration of A is known. Acceleration of A is known. Now, then we can find out U1, the velocity of A just before collision. So, velocity of A just collision, velocity of A just before collision is equal to U1 given. Then from the kinematic formula, we know 1 square will be equal to its initial speed 1 square minus 2 into acceleration is 2 multiplied by the distance 0.16. Here, since acceleration is negative, so there is a minus sign. So this is equal to 1 minus 2 are to 4 into 16, 64. So 0.64 is equal to 36. So we get U1. So U1 is equal to 0.06 meter per second. This is one important information. This is the collision velocity of the first body. So for the at the time of collision, what do we get? At the time of collision, we can write here just before collision. So velocities of U1 just before collision, U1 is equal to 0.06. Sorry, this is not 0.06. I'm very sorry. This is 0.6. 6 because U1 square is 0.36. So this is 0.6. That means U1 is equal to 0.6. Velocity of the second body before collision, U2 is equal to 0. And after collision, velocity of A after collision equal to say V1 and velocity of B and velocity after collision equal to V2 set. So from the theory of conservation of momentum, so considering the conservation of momentum principle, we find that the mass 2 kg multiplied by mass of 2 kg I'm sorry, there was a disturbance. So from the center of momentum theory, from the theory of conservation of momentum, we can write 2 kg multiplied by its velocity 0.6 plus For the second body, its mass and velocity is 0, will be equal to mass of the first body 2 kg, and its velocity v1, plus mass of the second body 4 kg and its velocity v2. From here we get 1.2, or let me write it here to save some space. 1.2 is equal to, let's say this is relation 1. Let us say this is relation 1. Now, what we have considered, and let us now find out, and also the velocity of approach, since it is a perfectly elastic, velocity of approach velocity of separation. From this we find velocity of approach, the body A was moving at a speed of 0.6 and body B was static. So velocity of approach, from here we get 0.6 minus 0 will be equal to, let us consider V2 minus V1. Assume that V2 is more than, assume V2 is more than V1. And both are towards right. Right? Okay. From here we find minus V1 is equal to 0.6. This is another relation 2. So we have a relation 1 of V1 plus V2, and we have a relation 2, which is V2 minus V1. Now we solve them from equation 1 we get, V2 is equal to, no, sorry, from equation 2, not from equation 1, from equation 2. From equation 2, we get V2 is equal to 0.6 plus V1. 0.6 plus V1. So from equation 1, now we put this value of V2 in equation 1. From equation 1, we get 1.2 is equal to 2V1 plus 4 into V2 is 0.6 plus V1. That means, or instead of that means, I write equal to, I continue solving this, simplifying this. This is equal to 2V1 plus 4 is 6 is 24. So 12.4 plus 4V1. This is equal to 4V1 plus 2V1 is 6V1 plus 2.4. From here we get, so on our left hand side was 1.2. And on the right hand side, we have 6V1 plus 2.4. Therefore, 6V1 is equal to 1.2 minus 2.4. This is equal to minus 1.2. 2. Therefore, this gives V1 is equal to minus 0.2. This is one value of, this is the value of V1. That means we have considered V1 and V2 both towards right. That means what we find now, that after collision, actually, B will move towards right and A will bounce backward with a velocity V1 equal to 0.2. A will bounce back and D will be in the forward direction. Let us see how far B goes. Now, we have V1, so we can now easily find out V2 again from the equation 2. From equation 2. From equation 2. Equation 2 is V, this was V2. V2 minus V1 was 0.2 minus 0.2. This is equal to 0.6. Therefore, V2 0.6 minus 0.2 equal to 0.4 meter per second. So we find that body. So we found that the two bodies, they are moving in opposite direction. This B is moving towards right with velocity V2, that is 0.4 meter per second. And it has got a frictional force which is working against this frictional force Fs, and there is A is moving towards left with a velocity 0.2. Once again, it will have a frictional force in opposite direction. You can handle both of them separately. Here, this is say Fs1, this is Fs2. So if we draw a kind of a line of separation here, then we find frictional force Fs1 is equal to mu 0.2 into its m is 2 kg into g is 10 is equal to 4 Newton. So naturally its acceleration A1 will be equal to 4 by 2 meter per second square. But this is actually a retardation because the force is acting opposite to the motion of the body. So then by going the kinematics formula, just writing the formula, you remember V square equal to U square minus 2S. This is the kinematic formula. We don't bother much about this. This is the formula. Using this formula, we can write final velocity 0 is equal to initial velocity 0.2 whole square minus whole square minus 2. Its acceleration A is 2 into, say, it moves a distance S1. Let us say it moves a distance S1 and this moves a distance of S2. This is assumption. From here we get 4S1 is equal to 0.2 whole square equal to 0.04 Therefore, S1 equal to 0.01. This is one value. Similarly, we can find out the S2. Here, Fs2, the here the frictional force Fs2 is mu 0.2 into its weight for its M4 kg into G 8 Newton. So its acceleration A2, once again, it is negative acceleration. A2 is equal to force 8 Newton divided by its mass 4 is equal to meter per second square. So by the same equation, 0, final velocity 0 square is equal to initial velocity 0.4 whole square minus 2 into acceleration is 2 into S2. From here, we get 4S2 is equal to 4S2 equal to 0.4 whole square, that is 0.16, 0.16. Therefore, S2 is equal to 0. That is so. What is the final separation between them? So, final separation of S1 plus S2 equal to 0.01 plus 0.04 is equal to 0.4 is equal to 0.05 meter, which is equal to 5 centimeters. So, this is the answer. Right? Now we shall go to the next problem.